Hi, this week we're going to begin by looking at proportions, and we've already talked about proportions a little bit with percents. But let's look at some examples here. So example 1, what this is saying is we want to find out, is 1/4 equal to 9/36? Okay? Now, there's several ways we can do this. So I'm going to show you a few different ways, and you can choose the method you like. So the method I'm going to use is, will 1/4, can we multiply both the top and bottom by the same number and get 3/36? That's the question. So, or 9/36, excuse me. So we know 1 times 9 is 9. So we start by picking out or finding out what 1 times 9, or what, how many times 1 goes into 9. That's 9. And then we have to multiply by the same thing on the bottom. 4 times 9 is 36. And so sure enough, that's the same thing. This proportion is an equal proportion. Another way you could go about this would be to find 1/4 as a fraction. It's 0.25, and 9/36 as a fraction. It's also 0.25. So sure enough, they're equal. And yet another way would be to cross multiply. 1 times 36 is 36. 4 times 9 is 36. They're equal. So whichever way you prefer, you can use. So for example 2, we've got 12/18, and I'm going to go for the first method. And so I want to see, this time we're getting smaller, so we're going to have to divide. So 12 divided by what is going to give me 3? Well, that would be 4. 12 divided by 4 is 3. So that means I also need to divide the bottom by 4. 18 divided by 4 is 4.5. That's not 6. So they are not equal. For example 3, this time I'm going to use the second method because it just would work better for this particular problem. You may see later on in the examples. So $1.50, it says, divided by 8 ounces. That gives us, 0.1875. So basically what this is saying is that whatever this item is about 19 cents per ounce. And then we'll take 4.75 and divide by 27, and we get 0.1759, and it keeps going. And those are not equal. So we'll write that the proportions are not equal. Okay, so for example 4, we're just solving a proportion, and we've already done this. with our percentages. So we'll cross multiply. 35 times x is 35x. 15 times 33.25 is 498.75. We need to get the x by itself. So divide both sides by 35. And x is 1425. No units there, so we're done. And example 5, we're going to solve this proportion. So we've got $12.50 times P. You can use you can carry your units with you as you go or not. I usually don't. I just add them back on at the end. But if you're afraid you're going to forget them, carry them as you go. So we've got $12.50 times P. And that equals 26 times 240. Oops. I'll multiply first. 26 times 240 is 62.4. And we'll divide both sides by 1250. So P is 4. Does it tell us how much to round? No, I'm just go 992. And since the tops was in dollars and the bottom on the left is in pounds, then the bottom of the right must be pounds also. Don't forget your units. On to word problems. A company designs and produces video games. For every 8 games that the company designs, only 3 on average become great sellers. If they design 48 games, how many of these would the company expect to become great sellers? Okay, so we're going to set up a proportion where both sides of the fraction would be equivalent. And I usually like to put the smaller on top. It doesn't really matter. But in this case, 3 would be smaller, and that's our great sellers. And then the games produced, we'll put on the bottom. So for each fraction on each side of our proportion, each ratio, we're going to put the great sellers over the games. So first we've got that there were 3 on average that became great sellers out of every 8 games. And it says if they designed 48 games, so 48 is going to go on the bottom with the games, how many of these would be great sellers? And so now, cross multiply. 8 times G is 8G. 3 times 48 is 144. Divide both sides by 8. And there were 18, don't forget your units, on the top is great sellers. One more example. Number 7 says Paul's car will travel 480 miles on 18 gallons of gas. How many miles can he travel on 12 gallons of gas? So I'm going to put miles over gas. Again, if you did it the other way around, that's fine, as long as you've got it the same on both sides of your proportion. So the first statement says that there's 480 miles and 18 gallons of gas used. And then on the second, it says he can drive on 12 gallons of gas. So gas is on the bottom, and I'm going to find how many miles on the top. We have 18M equals 480 times 12, which is 5,760. Divide both sides by 18, and Paul can travel 320 miles, don't forget your units, on 18 gallons of gas. So the rest of this, you've got several problems to try. So you can work on those and let me know if you have any questions.